Hello everyone, today we're going to look at quadratic equations. So one of the main formulas for a quadratic equation is ax squared plus bx plus c, and this is generally called the standard form. The quadratic shape when we graph it is called a parabola, and it opens either upwards or downwards depending on the sign of a. So if a, the coefficient of x squared, is positive, then a parabola opens upwards, which means that it looks something like this. If a is negative, then it opens downwards, which is something like this. So it's the same shape, it's just possibly flipped kind of upside down. The vertex of the quadratic is the lowest or the highest point of the parabola that opens upwards or downwards. So again, if I have an upwards open parabola, then the vertex is the lowest point. And if I have a downwards facing parabola, the vertex is the highest point. So in either case, those are the vertex. Plural vertices, so those are the vertices. Each parabola has a single vertex. If you want to graph a quadratic, then we need to find certain points on the parabola. We need the y-intercept, and again, if we're looking at ax squared plus bx plus c, the y-intercept is 0, c. The vertex is h, k, where h is negative b over 2a, and then k is found by just plugging h into the original equation. Right, so this is y. So f of h is a y. We plug in h and we find k. And then the x-intercepts. Remember, the x-intercepts are where y is 0, and in order to find that, we're going to need the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll practice using them all. Once we have these points, in theory, that would be enough to draw the parabola. Sometimes, however, these points are the same, and we're going to need more points in order to actually draw it out. So we'll see examples of both of those situations. So graph the following by finding the vertex and all the intercepts. So we have y equals negative 2x squared minus 3x plus 9. The first thing we're going to do is find the y-intercept, which again is just c. So the y-intercept is 0, 9. Next, we're going to find h. So remember, that's negative b over 2a. So b is negative 3, so negative b is positive 3. A is negative 2, so 2a is negative 4. So h is negative 3/4. Now to find k, we need to plug that into our equation. So k equals f of negative 3/4, which is negative 2 times negative 3/4 squared minus 3 times negative 3/4 plus 9. So please use your calculator. You don't have to do this by hand. I want you to actually do it out and make sure you're getting the same answer. But you should be getting 10.125. So I've translated my negative 3/4 into the decimal version since I'm going to have to graph it. Decimals make more sense. So there's my vertex. And then the last thing I need to do is find my x-intercepts. So again, this is going to be using the quadratic equation. Hopefully you have that written down somewhere so you can use it. I'm not going to keep writing the whole formula up here. But we do have negative b plus or minus the square root of b squared minus 4ac all over 2a. So some things to note. Remember that b squared is always positive or 0. Right? B is negative 3, but when I square it, I get a positive 9. So make sure you're not being lazy when you plug it into your calculator, because a lot of people plug this into their calculator. That is negative 9. What we need is it in parentheses, because we need positive 9. We're squaring that whole negative 3. Okay? And another thing to note is that you're subtracting 4ac, and a is negative, so I'm going to be subtracting a negative, and that's why I have a positive here. It's 9 plus 72 because I'm subtracting a negative. So then use order of operations, clean that up, and you should be getting 3 plus or minus 9 over negative 4. And that's going to give me two answers. I'm going to have 3 plus 9 over negative 4, and I'm going to have 3 minus 9 over negative 4. So you're going to be careful with order of operations. Make sure if you're plugging this into your calculator you put the numerator in parentheses. You need to make sure you're adding and subtracting that 9 before dividing by -4. If you do it correctly, you should be getting -3 and 1.5. Remember, these are x-intercepts, so they have the form something comma 0. So -3 comma 0, 1.5 comma 0. So then the last step is to plot all these points, or the second to last step, I guess. So 0, 9 is right here, around here. -3, 0. These are slightly off, but that's fine. 1.5, 0. I'll make that look better. Oops. There we go. And then the vertex. So the vertex has a lot of decimals, so I'm going to get, as close as I can. But -7.5, 10.125, that's slightly off my graph. That's going to be right around there. So one thing to note, your vertex is always going to be the midpoint of your two x-intercepts. So whenever you have two x-intercepts, you'll never have more than 2. But when you have 2, your vertex is right in between them. So if I looked at -3 and 1.5 and I found the midpoint, it should be -0.75. So that's one way to make sure that you're doing it correctly. Okay, so I have my points. Remember, the vertex in this case is the highest point because my parabola is facing downwards since a is negative. So make sure when you're drawing this out and you have your parabola, your vertex is actually your highest point. And then I'm just going to connect them. And then another thing to notice about parabolas is that they are symmetric. So just like the vertex is the midway point of my two intercepts, if I drew a line down the middle of my graph, and I drew it straight, and then folded it along that line, my parabola should match up. So if I have a point over here, equidistant from it, I'm going to have the same point in the y direction here. Whatever this point is, this point's going to be the same in the y value as long as I'm the same distance away in the x value. Okay, so it is symmetric about the vertex, that vertical line going through the vertex. So that's something to keep in mind, and we're going to use that when we don't have enough points to draw our picture. Let's try another one. Y equals 3x squared minus 6x plus 3. So again, the easiest thing to find is the y-intercept, 0, 3. Next, h negative b over 2a. So negative b is positive 6, 2a is 6, 6 over 6 is 1. To find k, I'm going to plug 1 into my function. So 3 times 1 squared minus 6 times 1 plus 3. And I should be getting 0. So the vertex is 1, 0. Next are the x-intercepts, and again we're going to be using the quadratic formula. So negative b, 6, plus or minus the square root of negative 6 squared, 36, minus 4 times a times c is 4 times 3 times 3. That's 4 times 9, which is also 36, all over 2a. One thing to note here that's really nice is that if I look at just these two parts here, that is the same thing as h. So 6 over 6 is another way to show that the x value of my vertex is 1. Clean this up. Root 36 minus 36 is 0. 6 plus or minus 0 is 6. 6 over 6 is 1. So in this case, we only have one x-intercept. In our previous one, we had 2. Sometimes you have 1, sometimes you have none. So in this case, we have 1, which we've already kind of mentioned, it's the vertex. If you do only have one x-intercept, it will be the vertex. Okay? So if I go and plot these 2 points that I have, we'll have the following. So even though I know the vertex is the 1, 0, I also know that our graph is opening upwards. So I have the general shape of this guy. But just those 2 points isn't enough. So what I'm going to do is I'm going to use the symmetry. I know that my y-intercept in the x direction is off by 1 from the vertex, going from 0 to 1. So if I go 1 again away from the vertex, I will have the same y value. So if I go 1 more in the x direction, which is 2, I'm going to have the same y value that I have in the previous direction. So I know that 2, 3, oops, right around there is also on my graph. Okay. And if you don't think this is enough to draw your parabola, it might not be. You can always do more points. So let's say I wanted to find where x is, say 3. So I'll plug 3 into my formula, and I will get out, let's say f of 3. So 3 times 3 squared minus 6 times 3 plus 3 gives me 12. So that means that I could use my graph. My graph only goes up to 10, so I'm going to have to guesstimate a little bit here, but it'd be right around, say, there. Again, using symmetry, I could use the fact that 3 is off of 1 by 2. So if I go back 2, which would be -1, I'd have the same y value. So at x equals -1, I'm also going to have 12. Okay, so using symmetry can help because I can double the points with half the math. And now here hopefully we can see our picture. Oops, that was terrible. Oh, that's terrible too. It's hard to draw on my iPad. That's quite terrible, but you get the point. You can draw it better with a pencil and paper. Okay, so it has the shape. It's opening upwards, like the A tells us because it's positive. My vertex is the lowest point, and my vertex also happens to be the x-intercept. And again, whenever you only have one x-intercept, it is the vertex. So if you find your vertex and you realize it's an x-intercept, you're done. You know there's no other x-intercept. And that's really helpful because it cuts down on some of the algebra. So the next one in standard form is going to be x squared plus 4x plus 6. So again, we start with the y-intercept, 0, 6. Then we move on to the x value of the vertex, -b over 2a. So b is 4, so -b is -4. A is 1. Remember, if you don't see a coefficient, it's a 1. So 2a is 2. And h is -2. We plug it in. So -2 squared plus 4 times -2 plus 6. And that should give us 2. So the vertex is -2, 2. Notice that's not an x-intercept, so we do need to find them. So according to the quadratic formula, we should be getting -4 plus or minus the square root of 16 minus 24 over 2. Now notice what's inside my square root is a negative number. 16 minus 24 is -8. And we can't take the square root of -8. That's an imaginary number. So because of that, that tells us that there are no x-intercepts. And I said before that's a possibility. You can either have no x-intercepts, one x-intercept, which is the vertex, or two x-intercepts. So now we've seen a combination of all three. So there's no x-intercepts. So sadly, the only point that I've actually found are the vertex and the y-intercept. So just like before, 2 points are not going to be enough, and I'm going to have to use symmetry. But first, I'll plot those 2 points. And before I start doing the symmetry, I'm also going to notice that A, like I said before, is 1, so my parabola will be opening upwards. I know my vertex is -2, 2. So I could draw half of my picture right now. It's going to look something like this, but I want to make sure I get the other side nice. So using symmetry, again, I notice that my vertex is -2. The y-intercept is 0, something, so it's off by 2. So if I go to the other direction, so namely to the left, -4, the y value is going to be the same. So I'm going to have the point -4, 6. And I can use that to draw the left side of my parabola. Okay. So you always want at least 3 points, the vertex, and then at least 2 points, one on either side of the vertex to draw your graph. But the more points you have, the more accurate your drawing will be. Okay. So that was all in standard form. The other form that we'll see a quadratic in is what's called vertex form. And this looks like y equals a times x minus h squared plus k. It's called vertex form because my vertex is right there for us, my h and my k. Notice, however, that this is a minus sign and this is a plus sign. So the sign of k is whatever the sign of k is in the equation. The sign of h is the opposite of what you see. Okay, so you have to keep that in mind when you're going about graphing them. But everything else before is the same. So graph the following by finding the vertex and all intercepts. So we have negative 2 times x minus 1 squared plus 8. Now in standard form, the y-intercept was the easiest thing to find, so we did that first. In vertex form, the vertex is the easiest thing to find, so we're going to do that first. So the vertex is 1, 8. Again, it's x minus h, so h is 1, and then plus k, so k is 8. To find the y-intercept, a lot of the times I'll have students tell me that it's 8. It's not 8. 8 is part of the vertex. It is not the y-intercept. Remember, the y-intercept is when x is 0. So x is 0. I do out order of operations, right? 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 8 is 6. So the y-intercept is 0, 6. The x-intercept, we do not need the quadratic formula. You could use the quadratic formula if you wanted to FOIL this out, distribute the negative 2, and then add the 8. So you could change this into standard form. I don't recommend it because it's a lot of work. Instead, remember the x-intercepts are when y is 0. So y equals 0. Just like with a linear equation, I'm going to get x by itself. I'm going to do order of operations backwards. So the first thing I got to do is get rid of that 8. And that will give us negative 8 equals negative 2 x minus 1 squared. Next, you got to get rid of that negative 2. So divide everything by negative 2. I'm kind of running out of room here, so I'm going to just draw on the graph side for now. Negative 8 divided by negative 2 is, positive 4. And I'm left with x minus 1 squared. Now, if 4 equals something squared, I want to square root, but I also need to remember that negative numbers exist. This is one of the biggest things that I see people do, is they'll square root both sides, and they'll get x minus 1 on one side, and they'll get 2 on the other. However, negative 2 squared is also 4, so we need that plus or minus. That same plus or minus that's coming from the quadratic formula. So x minus 1 equals plus or minus 2. So x equals 1 plus or minus 2 after I add the 1 over. So 1 plus 2 is 3. 1 minus 2 is negative 1. So I have 3 and negative 1. And again, I can double check that by making sure that the vertex is the midpoint of my 3 and negative 1. And it is, because it's off by both of them by 2. Okay, so don't forget, you can always check it by using symmetry. So now that we have these points, I'm going to graph them. So once I have them graphed, I'm going to make sure that my points make sense with what I know about my graph. A is negative, so I know my parabola is opening downwards. And my vertex better be the highest point. And the vertex is this guy, and it is the highest point. So hopefully these are enough points for you to draw at least a halfway decent parabola. And it's going to look something like that. Again, it's not perfect. It's kind of hard to draw on an iPad. Okay, so let's try another one. Y equals 3 times x plus 2 squared minus 3. So again, the easiest thing to do is the vertex. So the vertex is negative 2, negative 3. Again, this is x plus 2 is x minus h, so I have a double negative, so h is negative 2. For the y-intercept, I plug in x is 0. So 3 times 0 plus 2 squared minus 3. 0 plus 2 is 2, 2 squared is 4. 4 times 3 is 12. 12 minus 3 gives us 9. The x-intercepts. Again, I set my y equal to 0. I'm going to add 3 to both sides. I'm going to divide both sides by 3 to get 1 equals x plus 2 squared. Again, when I square root it, I have to remember that negative numbers do in fact exist. So x plus 2 is either 1 or negative 1. And then subtract 2 from both sides. And I end up with x is negative 2 plus or minus 1. So it's kind of opposite from what we had before. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. So we have negative 3 and negative 1 as our x-intercepts. And again, the vertex is the midpoint of those two numbers, so our answers make sense. And then what we want to do is graph them. Once we have them graphed, again, we want to make sure our picture makes sense. Our vertex is opening upwards, A is positive. So in general, it looks like this. My vertex makes sense, and I have at least one point on either side of my vertex, so I can draw it. And that was kind of terrible. That's better. Make sure that you're graphing your parabolas throughout the whole graph. Don't just make them really tiny, right? You want to make sure it extends beyond the borders of the graph. Okay. So make sure that you read through the book and that you try out the homework, and let me know if you have any questions. Thanks.